Lesson 3.8 on page 131 of your big text is about ordered pair relationships. Our essential question: how can you identify the relationship between points on a coordinate plane? The relationships being, we're going to find out whether they're both positive, both negative, or combinations of that. The four regions of the coordinate plane that are separated by the x and y axes are called quadrants. This is the x-axis, this is the y-axis, and these are the four quadrants that are separated by these two lines. Quadrants are numbered with the Roman numerals 1, 2, 3, and 4. If you know the signs of the coordinates of a point, you can determine the quadrant where the point is located. All right. The signs being whether they're positive or negative. That's what that means. The point -3, 4 represents the location of a bookstore on a map of a shopping mall. Identify the quadrant where the point is located. All right, so we're going to figure out which quadrant it's in. So, what is the x-coordinate of the point? It's -3. X always comes first in an ordered pair. And what is the y-coordinate? It's +4. If there's no sign, that means it's positive. Find the quadrant that contains -3, 4. Examine the x-coordinate. The x-coordinate is -3, so the point is 3 units to the left. So starting from here, it's 3 units left, right there. Since the point is to the left of the margin, it must be located in either quadrant 2 or quadrant 3. Has to be over here. It can't be over here because we're to the left. We're over here in this area. Quadrant 2 or quadrant 3. Use Roman numerals to indicate quadrants. Examine the y-coordinate. The y-coordinate is 4, which is positive. So the point is 4 units up on the y-axis, up. It's right up here. So the point is above the origin. It must be located in quadrant 2. So it could be 1 or 2, but we're also comparing it with the x, which was 3 and 2. The quadrant where 4 and -3 intersect is quadrant 2. Check by graphing the point, which we just did, on the coordinate plane. So the point representing the bookstore is located in quadrant 2. Okay, on the back side is the second half of our lesson. A figure has a line of symmetry if it can be folded about a line so its two parts match exactly. If you cut out the isosceles triangle right here at the right and fold the isosceles triangle on the right, fold it along the dashed line, the two parts would match. A line that divides a figure into two halves that are reflections of each other, reflections like in a mirror of each other, is called the line of symmetry. So this is the line of symmetry. All right, so this is a line of symmetry in this triangle. If I fold it on the line of symmetry, it is exactly along the line of symmetry. There's no edge sticking out because it's perfectly even on both sides of the line of symmetry. So that's a good example. This is a non-example. This is a bad example. This is not a line of symmetry. Even though I've folded it so that it touches the next side, there's all this stuff hanging out. Okay, you can't have stuff hanging out or it's not a line of symmetry. So this is not a line of symmetry. This is a non-example. So this is a line of symmetry because when you fold it, nothing hangs out on either side. Okay? Okay, back to the lesson. Here we go. You can use the idea of symmetry to analyze the relationship between points +5, -1, and -5, -1, whose coordinates differ only in their signs. All right, let's see what happens. Identify the lines of symmetry in the triangle. The blank axis is a horizontal, so that's our x-axis line of symmetry. And the other axis would be our y-axis, and we know that we're correct because it says vertical here, and this line is vertical. So the y-axis is a vertical line of symmetry. So in other words, if you took this graph right here and you folded it in half along the y-axis, the 1s would touch, the 2s would touch, the 3s would touch, the 4s would touch, and so on. Same thing, if I folded this along the x-axis, the 1s would touch, the 2s would touch, the 3s would touch, and so on as you went down. All right, so look at points A and B. What do you notice about the x coordinates? Where are points A and B? A is here, B is here. What do we notice about them? Well, okay, we notice we're looking at our x coordinates and they look the same. They're both 5. But what do we notice about the y coordinates? They're both negative. So we're going to say the x coordinates are the same, but the y coordinates are opposites. Remember from earlier in the chapter that if one is positive and one is negative, they're opposites. All right, so now we're going to look at the next question. Point B is a reflection of point A across which axis? A point of reflection. In other words, and how do you know? If I darkened in point B, and let's say that was actually paint, and then I folded this paper along the x-axis, making sure it was perfectly folded, this black dot, if it was paint, would put a black smudge right there, wouldn't it? If I went like that and pressed them together, it would make a black smudge right there on point A. All right. So how do I know this? All right, so it's a reflection across this x-axis. That's the one we folded on. So that's the first question. Point B is a reflection across which axis? The x-axis. How do I know this? If you fold the rectangle, whoops, am I on? I'm not on. If you fold the rectangle about or across the x-axis, point B and point A will touch. Okay, So now we're going to look at points A and D. What do you notice about the x coordinates? What do you notice about the y coordinates? So now we're on A and D. Well, first thing I notice is that the x coordinates are opposites and the y coordinates this time are the same. They're both positive. These are both 5s, but one's a -5, one's a +5. These are just both +4. So, okay, what do we notice about the x coordinates? The x coordinates are opposites. The y coordinates are the same. They're both +4. All right, point D is a reflection of point A across which axis, and how do you know? Okay, so it's a reflection of A. If I want those 2 points to touch, which axis am I going to fold on? I want the 2 points to touch. This time I blacken in point D and I want it to touch point A, and I want it to get some of that black ink on point A, I'm going to reflect across the y-axis this time. See how I'm folding it on the y-axis? All right. So the y-axis if, again, you fold the rectangle about the y-axis, points D and A will, will touch. Still messing up. Will touch. Okay. Which point is a reflection of point B across the x-axis? All right, so now we're looking at point B across the x-axis, which is here. So which one is a reflection of point B across the x-axis? Point A. What does this ask? Which point is a reflection of point B across the x-axis, and then the y-axis? So the reflection so we started with point A. Sorry. So we got to point A. We reflected across the x-axis. Now they want us to take that new spot and reflect it across the y-axis over there. So what is the final point we get to? First we reflected to A, then we reflected over to D. So that's what they want us to write. I'm sorry. Point D. So a reflection of point A across the x-axis, and then the y-axis gets us over to D. All right, compare the coordinates of point B with the coordinates of point D. So let's take a look at those. Point B, I have a +5 and a -4. Point D, I have a -5 and a +4. These are perfectly opposite. -5, +5, +4, -4. I'm going to say both the x coordinate and the y coordinate are opposites. All right, the rest we'll do together in class. Let's take a look at our notes. All right, here we go. 3.8, ordered pair relationships. Quadrant names are always named with Roman numerals, 1, 2, 3, and 4. Positive and negative are opposites. So in quadrant 1, both the x and the y are positive. Quadrant 2, the x is negative and the y is positive. Quadrant 3, they're both negative. And in quadrant 4, the x-coordinate is positive and the y-coordinate is negative. When both x values are the same, points are the same. When both x values are the same, points are reflected across the x-axis. So if they're both positive, or both the same, or both negative, it's being reflected, across the x-axis. When both y values are the same, the points are reflected across the y-axis. And here we have positive 20 and positive 20, therefore it would be reflected across the y-axis. All right.